The weather outside your window right now, whether it's sweltering heat, freezing cold, or perfect spring weather, is being controlled by invisible rivers flowing beneath the ocean's surface thousands of miles away. These underwater highways carry more water than all the world's rivers combined, and they're the reason London isn't frozen solid and Miami isn't a desert. Welcome back to World Explained. Yesterday we explored how moving continents shape our lives. Today we're diving into the moving oceans that control our climate. I'm your guide through the fascinating world of ocean currents, the planet's circulatory system that keeps our weather patterns alive. Picture this. Right now, there's a river flowing through the Atlantic Ocean that's 30 times more powerful than the Amazon River. But instead of flowing on land, it's flowing underwater, carrying warm tropical water northward at 4 miles per hour. This is the Gulf Stream, and it's just one piece of a massive global conveyor belt that never stops moving. Ocean currents are like highways for heat, salt, nutrients, and even weather patterns. They're driven by wind, differences in water temperature, salt content, and the Earth's rotation. There are two types of currents. Surface currents, driven mainly by wind, and deep ocean currents, driven by differences in water density. Surface currents affect the top 400 meters of the ocean. Deep currents can flow along the ocean floor for thousands of kilometers. But here's where it gets interesting. The Earth's rotation actually bends these currents. In the northern hemisphere, currents curve to the right. In the southern hemisphere, they curve to the left. This is called the Coriolis effect, and it's why ocean currents form these massive circular patterns called gyres. Imagine a single loop of water that takes 1,000 years to complete one journey around the entire planet. This is thermohaline circulation. Thermo for temperature, haline for salt, and it's arguably the most important current system on Earth. It starts in the North Atlantic. Here, warm surface water from the tropics arrives and begins to cool. As it cools, it becomes denser. Add the extra salt from evaporation, and this water becomes so heavy it literally sinks to the bottom of the ocean. This cold, salty water then flows along the ocean floor all the way to Antarctica, then branches off toward the Indian and Pacific Oceans. Eventually it warms up and rises back to the surface, completing a journey that takes centuries. This massive circulation system redistributes heat around the planet. It carries warm water toward the poles and cold water toward the equator, moderating temperatures worldwide. Without it, the tropics would be unbearably hot and the polar regions would be far colder than they already are. Let's talk about how these currents actually control your weather. The Gulf Stream alone transports as much heat northward as 1 million nuclear power plants. This is why Western Europe enjoys relatively mild winters, despite being at the same latitude as Canada. London, England is at roughly the same latitude as Labrador, Canada. But London's average winter temperature is 20 degrees Fahrenheit warmer. That's the Gulf Stream's gift to Europe. In the Pacific, changes in ocean currents create El Niño and La Niña, climate patterns that affect weather across the entire globe. During El Niño, warm water spreads across the Pacific, bringing heavy rains to California and droughts to Australia. La Niña does the opposite. These Pacific patterns can trigger hurricanes in the Atlantic, monsoons in Asia, and even influence the growing seasons for crops worldwide. A temperature change of just 2 degrees in Pacific waters can cause billion-dollar weather disasters on the other side of the world. Ocean currents also fuel hurricanes and typhoons. These storms need water temperatures above 80 degrees Fahrenheit to form and strengthen. Warm currents provide this energy, which is why hurricane seasons coincide with when ocean temperatures peak. Ocean currents don't just move water, they move life itself. Nutrients from the deep ocean rise to the surface along certain currents, creating some of the most productive fishing grounds on Earth. Off the coast of Peru, the Humboldt Current brings cold, nutrient-rich water to the surface. This process, called upwelling, supports massive populations of fish. Peru's anchovy industry, one of the world's largest fisheries, exists because of this current. Sea turtles use currents like highways, riding them across entire ocean basins. Young loggerhead turtles born on beaches in Japan ride the North Pacific Current all the way to California, then back again, a journey that takes decades. Unfortunately, currents also concentrate pollution. The Great Pacific Garbage Patch exists because currents trap floating plastic in the middle of the North Pacific Gyre, creating an area of concentrated waste twice the size of Texas. Here's what's keeping climate scientists awake at night. These currents that have remained stable for thousands of years are starting to change. The Atlantic's circulation system has weakened by 15% since the 1950s. As global temperatures rise, ice melts in Greenland and the Arctic, adding fresh water to the North Atlantic. This dilutes the salt content, making the water less dense and disrupting the sinking process that drives the entire system. If this circulation slows down or stops, something that's happened before in Earth's history, Europe could actually cool even as the rest of the planet warms. Regional weather patterns that billions of people depend on could shift dramatically. We're already seeing changes. The jet stream, which is influenced by ocean currents, has become more erratic, causing extreme weather events like the polar vortex that brought Arctic temperatures to Texas, or heat domes that broke temperature records across the Pacific Northwest. Today we monitor these invisible rivers with a network of floating sensors, underwater robots and satellites. The Argo program deploys thousands of robotic floats that dive 6,000 feet deep, measuring temperature and salt content as they drift with the currents. This data helps meteorologists predict weather weeks in advance, and climate scientists understand how our changing planet affects these crucial circulation patterns. Every hurricane forecast, every seasonal climate prediction relies on understanding these underwater highways. The next time you check the weather, remember that your local forecast is connected to a vast, invisible network of moving water that spans the globe. The ocean currents flowing beneath the waves right now are carrying the seeds of tomorrow's weather from thousands of miles away. These underwater rivers have been shaping life on Earth for millions of years, and they'll continue to influence where we can live, what we can grow, and what kind of planet we leave for future generations. Here's my question for you. What's the most extreme weather you've experienced? And now that you know about ocean currents, can you guess which current system might have influenced it? Drop your thoughts in the comments below. If this deep dive into ocean currents opened your eyes to how connected our planet really is, smash that like button and subscribe for more eye-opening explanations of our world. Don't forget to ring that notification bell so you never miss an episode. Tomorrow we're uncovering why time zones exist and how they work. Trust me, the story is more political than you think.